Now let's look at the fourth and the last example problem, partition array for maximum sum. So we are given an array A, and we want to partition the array into continuous subarrays so that each subarray has length at most k. And the goal is to, so after partitioning each subarray, all the elements in the subarray value are changed to become the maximum value of the subarray. And the goal is to find out the partition so that the sum of the changed array is maximized. So you can view this as a grouping elements, continuous elements, into size, group size at most k, and the maximum value in that group is used as representative. And we want to optimize the sum of this array after partitioning. So just to be concrete, so here is the example input. So I encourage you to think about what should be the output for this test case. How do you partition it? So each partition group should be at most k. So in this case, k equals 4, but it can be fewer than k in each group. So I encourage you to pause the video and come up with a number and then see whether you have it correct. So the output is 81, and here's the explanation. So I guess if I were to solve this problem manually for this particular instance, obviously we have 2 9 here. We want to, no, actually I changed the example in the middle. Yeah. So we want to use the biggest element as much as possible. However, even though this is this 9 here is the biggest, it's actually not optimal to use this 9 for the group of 4, because then for these 2 small numbers we cannot use 8 for them. So 8 is the second biggest. And if we use 7 here, but then we cannot use 7 for the early element. So it turns out the optimal one is actually use this 9 only for the last 2, and then this 8 cover this 4, and then this 7 cover this 3, and then we have 5 and 1 here. So if we use this 7 to also cover this 5, then the first one doesn't have any other number. It will just remain a 5 and remain a 1. But grouping it, this makes this both of these 5. So we have a 10 here, 21 here, 32 and 18. So now, having solved this manually, I encourage you to think about how you would solve this problem using a program for any input and any size. Oh, so I didn't put down the parameter size here, but this problem can be solved in complexity of n times k, where n is the size of the array. So when k can be as larger than, it will be quadratic. But when k is smaller, then it's linear, up to a factor of k. So how do we build solution from partial one? In general, the way to at least for me, I would like to think about the DP problem often as a case analysis. So I assume that sub problem have been solved, and then I'm just trying to solve the last step. So in this case, I can assume that sub problem would mean optimal ways of partitioning for prefix of this array. So I assume that has been solved. Now I'm just trying to solve the last step. Then I do a case analysis. So what are the possibilities for the last step? Now in this particular case, there are 4 cases, right? So either this the case will be based on how large is the last group, the last partition. So if it contains just 1, then it's just this element 3. Or it could be containing 2, 3, and 9, or could contain 3 elements, 3, 8, 9, 8, and could contain 4 elements. Now, if I have solved the problem for all prefix, now figuring out the answer for this is easy. I just consider each of the case and what I get for that case, and then I choose the max. and that solve this problem. So essentially, the key here is to do the case analysis. First, define a DP relation so that enable the case analysis would work. So I encourage you to write down the DP relation, both the definition of what your DP, the DP will take a parameter which is the index, so which is basically the length of the prefix. So what it means, and also what is the recursion relationship that enable you to compute the particular DPI value. And this is my way of writing the DP relation. So consider all possible value I, where I essentially is the prefix length. So since from I plus 1 to no, actually I think my DP relation is I'm reusing the same local variable here, so that's a little bit bad. So let's change these. Yes. So essentially, this is the case. And here I use this I to indicate the length of the prefix. So then the solution will be the already the prefix solution plus j minus I. This is the number of elements in the last group, and this bound makes sure that j minus I is at least 1 at most k, and this is the maximum element in this range. Not. Yeah, so k goes from j minus I should be I plus 1. Yeah, k goes from I plus 1 to j. So can find out the biggest element in that group, and this will be multiplied by the size of the group. And this is my code for this problem. It's pretty short. Essentially just implementing the logic. I think you can all figure this out based on the understanding. And the last problem in this problem set uses something similar to the idea is similar to this problem. You need to consider the last step, do a case analysis. So that's the end of topic 3. So enjoy the problem set.